Hello, welcome back my dear friends. A very good morning, good evening and good afternoon to all of you. This is the TQM1 course and this is lecture number 11. I am Raghunandan Sengupta from, as you know, from IME department, IIT Kanpur. So, as we are discussing about Kaizen and the implementation, how Toyota as a company considered the concept of Kaizen and concept of total quality in its overall spheres. So, we will continue with the 7 tools of quality assurance and how they have changed accordingly as the overall progress of different technology, different services occurred in different spheres of manufacturing and for different areas of the economy. A comprehensive statistical process control system uses 7 actual concepts or tools to reduce variability and eliminate waste. And if you remember, elimination of waste, reduction of variability, reduction of total cost, negative cost I am considering, trying to basically implement the concept of quality are the different important bullet points for the 3 stages of quality. If you remember the examples which I just mentioned as examples for Motorola, GE and all these things. So, one is the histogram or the stem and leaf plot and how they are implemented and utilized as statistical process control tools. I will come to that. Then you have the checklist or the check sheet. Then you have the concept of Pareto charts and the concepts of Pareto analysis, how they can be utilized. Then you have the cost effect diagram, the trying to analyze the actual result based on what are the effects which have happened earlier. You also consider the defect concentration diagrams and how they can be reduced. You consider the scatter diagram, control charts. This will be discussed separately in greater details later on. So, I will come to the control charts of X bar charts, R bar charts, P charts and all those things. So, stem and leaf diagrams are basically graphical representation of the data in numbers or in graphs. So, let there be a set of 9 numbers. So, the 9 numbers are basically starting from 101, 2, 3, 4, 5, 6 and so on and so forth. So, to construct a basic stem and leaf, which basically if you see the stem and leaf of a plant or a tree, the main branch has different type of stems and leaves coming out. So, basically the overall emphasis, if you see, the numbers 1, 0 are common for all the 9 numbers. So, we will consider them as the main stem and the leaves would be basically the adjoining numbers after 10, which basically makes the sequence or the series of numbers. So, it will be to construct a stem and leaf, the numbers are divided into 2 parts, the stem and the leaves, and hence the stem would be 10 and the leaves would be 1, 2, 3, 4 till 9. In case, say for example, it was 11, 12, 13, 14 till 19. So, obviously, we will have the stem and leaf accordingly. It could have been, say for example, numbers are 1001, 1002 till 1009. So, in that case the stem would be 100 and the leaves would be again as mentioned here 1, 2, 3, 4 till 9. So, generally the number of stems should be less and obviously the leaf would be the corresponding last or numbers based on which you are trying to work. So, this Nag table which is 3.1 and all these things have been taken, if you remember I mentioned time and again when we were discussing, are taken from the Montgomery's book of statistical process control and the concepts therein. So, here in table 3.1 we consider the cycle time in days to pay employees health insurance claims. So, the claims are if they are 1, the days claims are given accordingly. So, claims 1 till say for example 40 are given and all the dates are given or days are given based on which the claims can be settled. So, if you do the stem and leaf display, so the days are the stems and the leaves are the number of days are there in the overall things. So, you have a leaf unit of 1. So, if it is say for example leaf of 3, the unit is 1 and based on that you have the numbers which are given in figure 3.1. So, that will give you how the idea of the stem and leaf is done. Above example is ordered which makes it easy to find out the percentile. So, here if you remember the claims are given from 1 to 40. So, if they are jumbled obviously you have to make a sequence of how the claims are being done based on the number of days. So, the 100kth percentile is a value such that at least 100 or k percent of the data values are at or below the value, and at least 101 minus k percentage of those values would be basically be at or above the value. So, basically if you are considering 50%, 50% will basically have half of the data, half of the probability. If you remember the probability part, I mentioned quite in detail when we were considering the CDF and the PDF for the normal distribution. So, the 50% which is the mean or the median or the mode for the normal distribution, it will imply that 50% of the data is onto the left of the mean or the median or the mode, and the rest 50 would be on the right hand side. So, if you are looking from your side. So, obviously different distributions as they are used would have different medians and different mean values also, but the uniqueness or the speciality of normal distribution is because the mean, median, mode are the same values. So, in histogram the concept is their continuous data is divided into intervals which are called the class intervals, cells or bins, and obviously the class intervals are done in such a way they are of equal no, I will not use the word dispersion, they are of equal breadth. So, if you are trying to basically find out the number of students who have, say for example, the number of family members between, say for example, 2 to 4, then another would be, say for example, from 5 to 7. So, obviously the bins or the intervals are 2 in number. So, you will basically find out number of people who are there with that family numbers and note down and add up the whole value to find out the total number of the frequency. The number of bins does not have any agreed rule. So, but in technically one of the heuristic is basically as given here, where the number of bins is h is equal to 1 plus log to the base Neperian to the binary base 2 n, where n is the sample size and h is the number of bins which you want to basically have. So, obviously they without going to the rules, it will basically depend on what is your experience and based on which you are trying to basically divide the data into bins and try to understand what type of different type of distributions would be used and what analysis you can do from the data, such that it will give you some idea about the from the quality perspective. If you remember, this is not to do with statistics, but more to do with the concept of quality and how you can implement the different type of statistical quality tools in order to improve quality. Given a visual impression of the shape of the distribution of the measures, so it gives you quite a lot of information, and some information about the inherent variability in the data can also be found out from the histogram. So, the histogram, if you look at the middle value and they are equally dispersed onto the right or the left, obviously you will be able to say that the total amount of dispersion is equally balanced both onto the left or the right of the mean value. But now, when I am talking about variability, remember that variability or the word which we try to utilize in statistical terms is variance or standard deviation. They are based on the concept or what is the dispersion based on the fact that how big or how small they are from the mean value. So, variability can be considered at different points with respect to median, with respect to mode, and all these concepts can be utilized, but you will stick to the concept of variability based on the mean concept only. Histogram is the best suited for large data set, considering, say for example, 75, 100, 105 or 110 data points. So, the choice of the number of bins becomes less influential in determining the shape of the distribution. So, the larger the data size is, you will be able to appreciate that they will slowly turn out to be a normal distribution. So, this is the concept of so called central limit theorem, which I am just mentioning. It will be taken up later on as required. So, again the histogram is an example which is taken from Montgomery. So, they are the layer thicknesses and Armstrong. Armstrong is a unit of measurement on semiconductor wafers. So, the thicknesses are given here starting from 438 to 439, and if you see that you have basically 3, 6, 9 and 10 columns, each of them have the amount of reading which is noted here. So, if you basically divide into bins and draw that histogram, the histogram is given as shown here. So, along the y axis you have basically the frequency, and along the x axis you have the bins or the intervals, which are basically to do with the layer thickness in angstrom. Now, one should remember the bins or the intervals which you have made can be broader or smaller depending on what amount of information which you want. So, finer you make, more better the graph would be, and it will be able to give you a lot of information what is the overall distribution of so called thickness depending on the number of reading which you have. So, it would depend more on accurate working, but it does give you a lot of informations from the histogram, and whatever level of accuracy you want, that can be increased or decreased depending on the interval length. So, I am just considering the interval length. Efficiency on information can be increased from the statistics point of view using different tools, but let us only concentrate on the interval aspect only. So, the check sheets would be collection of the data, measure the overall idea which you are trying to get and the information which you want to get. Check sheet is used to collect the data in an organized manner, specify the type of data to be collected, the part of an operation number and the date, who are the analyst, who collected the data, how many different points were collected, at what point of time they were collected, and all the information is important. A trial run to validate the check sheet layout and the design can also be taken in order to accurately find out that the data which is being utilized is how good or how bad it is. Is it spurious, or is it the collection has been data has been done in the best possible manner? Those have to be checked. So, a check sheet is just given here for the information. So, they are technically, just I am giving a very brief background. So, the last two columns is basically has 2003 data and the total number of so called defects for the data, which are for year 2002 and 3, and the middle column is basically the yearly data pertaining to 2002, and the leftmost column basically has the entities or what are the different type of defects. They can be supply parts are rusted, misaligned weld is there, paints out of limits is there, voids in casting is there. So, all the different defects are basically marked on the leftmost column. So, the time oriented summary is particularly valuable in looking for trends or other meaningful patterns in order to understand how the overall process is going on and whether there are aberrations based on which you can take immediate actions to reduce the variability. So, the Pareto chart is basically the next concept, as we have discussed when we were going through the bullet points of discussion, is basically the Pareto chart is a frequency distribution or histogram of attributes data arranged by category. So, you will basically arrange them depending on what level and which areas they can be clubbed, used both in measure and analysis step. So, you have basically all if you remember on the leftmost column you have all the different type of defects. So, they have basically been put along the y axis and the number of defects are basically marked along the x axis. So, if you see the adhesive failure, they are 6 in number. If you see say for example, machining number, they are 29 in number. So, you can understand that what is the overall frequency of the errors which are occurring from different defects, and then you can basically understand the whole process and take corrective actions as required. So, the Pareto charts are they do not automatically identify the most important defects, but only the most frequent which are there. When the list of defects contains a mixture of those that might have extremely serious consequences and other of much less importance, one or two methods can be utilized in order to find out what is the level of such some importance which are there for the defects, which can actually adversely affect the overall manufacturing process or the overall service process which you are trying to study. Using a weighting scheme to modify the frequency counts can be done. So, the more the weights are or more the frequencies are, you give a higher weight, or later the more recent occurrence, obviously you can give higher weights, but obviously it will mean that there is some rationale based on which you are trying to give weights. So, for the time being we will consider weights can be done, but we will ignore that for our analysis and later see that how they can be taken up. So, Pareto charts as we discussed the so called stem and leaf diagrams and the overall analysis of the data which are there. So, it basically Pareto charts accompany the frequency of the Pareto charts analysis with the cost of or exposure of the Pareto charts and what are the overall implications from the cost perspective. So, the variations of the Pareto charts are given. So, component numbers are given, and on the y axis you basically find out the percentage of components inaccurately located. Then in the other diagrams again you have the components and all the wrong things which have been done, like the rust part, the paint being not there, casting being not done properly, welding being not done properly. So, all these are technically marked along the x axis, and the error frequency on the number of occurrences depending on how you want to find out the numbers. It can be frequency, relative frequency, percentage of occurrences, so and all these things are marked along the y axis. So, if you find out, so in the second diagram you have again the component, on the y axis you have the number of defective components. In the next two diagrams which have graphs where I am pointing my finger, you have the wrong, so called wrong numbers are there on the x axis, and on the y axis you have the error frequency, and so on and so forth for the fourth diagram also. So, the next idea which is very heavily used in statistical process control, total quality management, ideas how to implement them, is basically the cost and effect diagram. Once a problem has been identified, we have to look for the possible sources of the problem. Cause and effect diagrams are used to analyze and improve steps to find out potential causes and how they can be rectified. Also known as Ishikawa diagram, these methods find its application in both manufacturing and service sector in equal proportions. Several alternative classification methods of the causes and cause and effect ideas can be implemented such that we are able to increase the concept of quality, which we have been talking about for the last so called 10 number of lectures or 11 number of lectures, whatever we are trying to complete as of now. So, cause and effect diagram. So, the 5 M's are for manufacturing things are basically machine and technology, method or process, material which includes raw material, evaluation of what are the inputs, manpower both physical, mental, and how they are being implemented and utilized. Implemented in the sense that how you are able to utilize the services of those manpower. Measurements are basically to do with inspections. Some people have included 3 more M's, which are basically mother, nature, management and maintenance, but basically the main focus is to try to reduce the level of variance in quality and try to basically reduce the cost also at I will not use the word expense, but in such a way that both machines or methods or materials or manpower basically are utilized in the most efficient and optimal manner. So, the 8 P's in marketing are product and services, price, place, promotion, people and personnel, process, physical evidence and packing. So, obviously, they would also have a negative or a positive effect how they are being utilized in order to improve quality. The 5 S's used in service sectors are, so now we basically initially we discussed about the manufacturing sector, now they are the service sector. So, the 5 S's are surrounding, supply, system, standard documentation skills and the scope of work. Constructing a cause and effect diagram, so how do you do that? So, the steps are, I will just go through them simply very slowly. So, you define the problem or effect to be analyzed. So, what you want to study, you basically define the problem, where the problem is occurring, you try to identify and take and make a plan that what you want to understand or go into the details. Form the team to perform the analysis. So, obviously, there would be a core team. Core team, say for example, can be a good engineer, can be the workers working on the machine and all these things would be there. Often the team will uncover potential causes through brainstorming sessions, draw the effect box and the center line and basically see that where the outliers or where the overall output means the overall system is producing some output, can be services, it can be products, and you basically try to find out that where do the products stand with respect to the overall efficiency of production or overall efficiency of the quality concept. Specify the major potential cause categories and join them as boxes connected to the central line. So, basically there would be a central line and all the effects would be coming. So, if you remember a fish bone, so that would basically have some idea that how the cause effect concept can be done. So, the fish bone there is a main backbone and all the bones are connected to that. So, basically that is why the cause and effect can be analyzed accordingly. So, rank the orders and the causes to identify those that seem most likely to impact and take corrective actions accordingly. So, if you see This is the cause and effect diagram of the fishbone diagram. An example is given. So, the defects on tanks are there at the main concern, which is the main central line. And if you consider the 5 M's or the S's whatever there, they have been marked accordingly. So, they would be for this thing, they can be the machines, the materials, the methods which are there on the. So, where you place machines, materials, and that is immaterial. So, it can be on the upper half of the cause and effect diagram, it can be from the lower half of the cause and effect diagram, that does not matter. So, they would measurements personnel would be coming in the lower half, and how they affect your total number of defects in the tanks have different type of implications. So, say for example, for the machines, it can be one tool too much play is there, or the coolant is not being utilized adequately, or you are using wrong tool, or ambient temperature outside is very high, or they are dust, they are humidity. So, all these things are studied in such a way that you can at least find out what are the variables which affect the main component based on which you are trying to analyze the defects of the tank. So, once that is done, you basically analyze each of them individually and try to find out in a sense what is the level of importance based on which you can analyze all the inputs which basically makes the cause and effect diagram so effective. Defect concentration diagrams are there. A defect concentration diagram is a picture of the unit showing all relevant views. Then the various types of defects are drawn on the picture, and the diagram is analyzed to determine whether the location of the defects on the unit conveys any useful information about the potential causes of failure or causes of not so efficient performance of the system. So, as I keep repeating, not working efficiently does not mean the production is low. It can basically mean total cost is high, it can basically mean the overall technology which is being used is very old, still we are getting very bad products, or it can be that we are trying to utilize the new technology, still we are basically getting bad products. So, useful analysis in this step are only implementable and applicable as and when we try to implement all this sequence of the fishbone diagram, of the cause effect diagram, and which we basically the Ishikawa's diagram, and the concept of say for example, the Pareto diagram or the leaf and stem diagram, we are basically utilized in a collective sense in order to give the best possible picture or best possible set of information for the overall working process of the manufacturing unit or the service sector unit. So, defects are diagrams. I am just considering from diagram point of view. You have basically in this diagram which you are considering, the tank diagram is given from the top view, the left side view, the back, the front, the right side, and the defects are basically marked. And based on that, you find out the number of defect codes are done for A, B, C, D, or say for example 1, 2, 3, 4, depending on how you want to implement the overall system of defect and analyze the defect of the tank. Now, scatter diagrams are useful plots for identifying a potential relationship between two variables. Let us say data is collected in pairs of two variables x and y. Say for example, like I am giving a very simple example, it can be humidity and temperature when you are trying to find out what is the tensile strength of a product which is being manufactured, or it can be say for example, speed of the turning machine along with what is the temperature of the coolant which is being utilized, or say for example, in a service sector it may that be when the order for the food has been made by the customer and when actually the food is delivered. So, obviously, there would be some implications based on which you can study two or more variables in order to understand the overall process which you are trying to analyze. The shape of the plot of the y against x will give us some indication of the relation between x and y. So, scatter diagrams are very useful in regression models where you want to predict forecast of y depending on different set of variables of x which you have. It must be kept in mind that scatter diagrams give potential relationship and not causality. So, basically they give you a relationship, but actually they do not give you any actual cause and effect concept. Like say for example, I plot rainfall with say for example, age of the children in one district of India. So, obviously, I will get different type of plots, but what is the actual relationship, what is the cause effect, that may not be analyzed from the scatter plot diagrams which I have. So, you should be careful that drawing blindly scatter diagram may not give you the best set of information which you want. So, here you will basically utilize the concept of design of experiments of such that you are able to find out what are the actual variables based on which you can understand where the problem is, how the quality improvement can be done, how the total cost can be improved, in the sense the overall negative cost can be decreased or the variability can be decreased, and all these points are important. So, this is the scatter plot. The scatter diagram indicates a strong positive correlation between metal recovery and flux. So, for the diagram which we studied in few slides back, you have basically trying to understand that there are some problems in the tank. So, how they can be analyzed. So, you have in the y axis you have the metal recovery percentage wise, and you have the reclaim in flux in pounds in the x axis. So, based on that you can understand there is some relationship between x and y. An application of statistical process control improve quality and productivity in a copper plating operations at a printing circuit board. Fabrication facilities can be done. So, high levels of defects such as brittle copper and copper voids were there in the long cycle. So, they can be utilized and reduced in the actual run such that you are able to improve the quality. Improvement teams were formed for this example, for trying to find out the defect in the tank and trying to improve the overall working of the process. So, plating was done for the tank by the tank operator, the manufacturing engineer responsible for the process, and the quality engineers basically got together, brainstormed, find out the cause and effect diagram, analyze the problem, and then came up with a solution. They would basically define, concentrate on reducing the flow time through the process, as missed delivery targets were considered to be the most serious obstacle in improving the productivity of the whole working process of the example which you are considering. So, an application of statistical process control would be here you measure. So, excessive downtime in on the controller that regulated the copper concentration in the plating tank were major factors in the excessive flow time. Controller downtime translated directly into lost production. So, you will basically analyze, brainstorm, try to find out what are the cause and effect diagrams and what are the analysis, and basically take actions accordingly. So, this is a little bit cluttered, but here the cause and effect diagram for the controller downtime are analyzed, where on the upper part of the diagrams you have the reagent replenishing, paratronic pump failure, electrical failure, and all these things are analyzed, and how and where the problem occurred are basically dealt in depth. So, an application of statistical process control would be the data collection for the controller downtime was necessary, and the cause and effect diagram would basically have this. So, in the leftmost column you would have all the concentration variations, what are the failure causes, they were reagent replenishing problems were there, oxygen controller had a problem. So, all these things are analyzed, the operator basically goes into the error, gives a description on the second last column, and basically analyzes what are the actions which are taken to rectify that or remedy the whole set of actions which are taken. So, based on the data of the Pareto charts can be made. So, again you have along the x axis the different errors or the defects which are there, and you analyze the level of concentration, what are the defects, and the numbers which are plotted on the y axis, they would give you a good feedback that how the process is doing, and if improvements are done based on the feedback of the controller, the engineer, how they can be implemented for the whole system. So, with this I will end this lecture and continue with my 12th lecture the next day. Have a nice day and thank you very much.